Hello friends. So in this video we will be learning about equivalence partitioning and boundary value analysis. These are two software testing techniques and these will be very useful while testing. So let's start. So first let's talk about why do we need these techniques. So suppose you have a field where the allowed values are between 18 to 60. Age is the field and the value of age should be between 18 to 60. Okay. Um, the user cannot be less than 18 and the user cannot be more than 60. So how will you test that field? Are you going to test? You will write 18, that should work. You will write 19, that should work. 20, that should work. And so on till 60. No, you don't need to do that. You don't need to test every value. That will be, that will consume a lot of your time. So the purpose of these two techniques is to reduce your test cases and while reducing the test cases still maintain the coverage and find the defects efficiently. So what is equivalence partitioning? So the basic idea of equivalence partitioning is to divide your input range, to divide your input into groups that behave the same way, and you need to test only one representative from each group. For example, now your requirement was age should be between 18 to 60. So you can divide that input into three groups. One, less than 18, that should not be accepted. One, the second one, between 18 to 60, that should be accepted. And the third one, the greater than 60, should not be accepted. So you have divided your input range into three groups. So you will have three test cases. You can test one value 17, that should not be accepted. One value as 30, that comes in the valid range, so that should be accepted. And one value as 61. Since it is more than 60, that should not be accepted. So all values inside the same partition will behave same. So you can test only one representative from each partition, or you can say each group. Just divide your input range into divide your input range into groups that behave similarly and test only one value from that group. Okay. So here we have divided our input range into three groups: less than 18, 18 to 60 and more than 60. And we will test one value from each group like 17, 30, 61. Because all the values inside the same partition behave similarly. Let's take one more example. So the requirement here is the quantity of pizza could be only between 1 to 10. So less than 1 will be rejected. 1 to, so you can divide this input range 1 to 10 into three groups. Less than 1, 1 to 10 and more than 10. Less than 1 should be rejected, 1 to 10 should be accepted and more than 10 should be rejected. So again you have three cases. You can take value as 0, which is your negative test case. It should be rejected. Value between 1 to 10, that is 5, it should be accepted. And one value more than 10, that is 11, it should be rejected. So you need only three tests instead of 100 plus possibilities. Let's take one more example. So suppose you have a marks field and the value could be between 0 to 100. So again, this can be divided into three groups. Less than 0, 1, the other group will be between 0 to 100 and more than 100. Okay. So we have three test cases. Less than 0, you could take -5. That is your invalid test case. It should not be accepted. Then you can take any value between 0 to 100, let's say 50. So that should be accepted as that's a valid value. And then you can take one more invalid value that is more than 100, 101. That is an invalid value. It should not be accepted. So you actually don't need to test so many values like 1, 2, 3, 4, 5, 6, and so on. That will not provide any additional value to your test cases. So you can use this technique to divide your input range into groups and test one representative from each group. But equivalence partitioning can miss bugs. For example, the developer has written age is greater than 18 and age is less than 60. And you write 18. So 18 will not be accepted. If you write 60, 60 will not be accepted. But they should be accepted. And you have not tested these values. You have tested only less than 18, uh, between 18 to 60, and more than 60. You must test the boundaries. Because most of the bugs are found in the boundaries. Because here developer accidentally missed writing equal to. It should be age greater than equal to 18 and age less than equal to 60. So EP test only covered 17, 30, 61. But 18 and 60, they were not working correctly and EP could not detect that. That is, equivalence partitioning could not detect that. So because EP never tested the edges, the boundary values 18 and 60 would be incorrectly rejected, and the values between will work fine, but the boundary values will be rejected. And these errors are most common errors. That is, off by one errors and the boundary value errors, they are most common errors. So for that, we have another technique called boundary value analysis. So it detects frequently occurring errors at the boundaries of valid ranges. So boundary value analysis asks you to test the boundary as well as just below the boundary and just above the boundary. Boundary minus one, boundary plus one, and the boundaries. Okay. So that helps you test the exact edges where off by one errors hide. So let's say our example was accepted age is 18 to 60. So boundary value analysis cases will be first let's talk about the lower boundary, that is 18. So first it will be 18. 18 that should be accepted. Then boundary minus 1, that is 17. 17 should not be accepted. Then boundary plus 1, that is 19. 19 should be accepted. Then let's talk about the upper boundary, 60. 60 should be accepted. Then the other test case will be 60 minus 1, that is 59. That should be accepted too. And then 60 plus 1, that is 61. That should be rejected. So our boundary value test set will be 17, 18, 19 and 59, 60, 61. Let's take one more example of boundary value analysis. So our requirement is height should be between 120 to 200 centimeters. So our test cases will be first, let's talk about the lower boundary. So boundary value, which is 120, one less than boundary value, which is 119, and one more than boundary value, which is 121. And let's talk now about the upper boundary, 200, 200, one less than 200, which is 199, and one more than 200, which is 201. Okay, so that's how we test the boundary. And we test the boundary because most entry related defects, they occur around these limits. So there are very high chances that you will find defects here, so you must test the boundaries. Let's take one more example, ATM withdrawal example. So the requirement is it will accept only fields between it will accept only value between 100 rupees to 50,000 rupees. So what will our EP test, according to our equivalence partitioning testing technique, what will be our test cases? We will divide this into three groups. Less than 100, let's take that 50, which will be an invalid value and it should be rejected. Then another test case will be between 100 to 50,000. It could be 5,000. That's a valid test case and should be accepted. And then the third test case will be more than 50,000. That could be 5,001. So that's an invalid value and it should be rejected. And these are the test case according to our equivalence partitioning techniques. Now, according to our boundary value analysis technique at the boundaries, 100, 99, and 101. And upper boundary, uh, 49,999, 50,000, and 50,001. Okay. So these are our boundary value analysis test. So we have to combine these two tests in order to test efficiently. Let's take one more example, password example. So the length of the password should be between 8 to 20 characters. According to our equivalence partitioning technique, we can divide this into three groups: less than 8, between 8 to 20, and more than 20. So our values for EP test could be 5, 12, and 25. 5 and 25 should be rejected because they are less than 8 and more than 20, and 12 is a valid value and it should be accepted. And as per our boundary value analysis technique, we have to test at the boundary. So it will be boundary is 8, so 7, 8, 9, and our upper boundary is 20, so 19, 20, 21. So these will be the test cases for checking the length of the password, whether the password field is behaving correctly, whether the password length is correctly behaving or not. So equivalence partitioning technique is to reduce your test cases and focus more on the groups. So you divide your test into groups and only test one representative of that group. So that makes your test count smaller and still provides you a good coverage. But it does not find the edge bugs. For edge bugs, we have boundary value analysis technique. Okay, so it focuses on the boundaries. Though your test count is more than equivalence partitioning technique, but it provides better coverage and helps you finding the edge bugs. So our best practices is to use EP plus BVA together. You have to use equivalence partitioning and boundary value analysis together. For example, the very first example we discussed was age less than 18 should not be accepted, 18 to 60 should be accepted, and more than 60 should not be accepted. So according to boundary value analysis, the values will be 17, 18, 19, and 59, 60, 61. So these will be your test case. And according to your um, equivalence partitioning, you already tested less than 18 in boundary value analysis technique. You already tested greater than 60 in boundary value analysis technique. You can test one value between 18 to 60. Let's take that as 30. Okay. So that will be your equivalence partitioning test case. So our final test set will be 17, 18, 19, 30, 59, 60, 61. So now let's test your knowledge. So the requirement is username length should be between 5 to 15 characters. So you have to test the username field, the length of the username field. It should be between 5 to 15 characters. So pause this video now and try the test cases yourself. Then you can resume to see whether you did it correctly or not, which I am sure you will do it correctly. So let's reveal the answer. So our EP partitions will be less than 5, 5 to 15, and greater than 15. And our boundary value test cases will be 4, 5, 6, and 14, 15, 16. So if I want to summarize this, equivalence partitioning is to reduce your test cases. It helps reduce your test cases. And boundary value analysis is the one which focuses on the boundaries because most defects occur at the boundaries. And both of these techniques complement each other. And you should use both the techniques to test strategically and not exhaustively. Okay. So if you like this video, then please make sure to subscribe to my channel and I will keep creating more such videos. Thank you for watching.